I I saw this integral on YouTube. It was done by Laplace transformation. Now I have a different way to do it. Here I'm using Feynman's trick, so I'll want to share with you. Now I create a function f of a is equal to this integral cosine ax 1 plus x squared dx. Now then I can see that f of a 0 is equal to, this will be 1, right? This will be dx over 1 plus x squared. So that is equally arctangent x from this to that one, that is equal to pi, right? That's good. So I have an initial condition that f of a 0 is equal to pi. That is my initial condition. And also that my I is f of 1. Right? So my I is f of 1. Okay. Now then I take the derivative of f with respect to a. So I take this derivative with respect to a. So I take the partial derivative with respect to a. That would be sine ax, right? Negative times x is a constant, so times x again, the dx, and over 1 plus x squared. Yeah. Now here I'm multiply by x both to the numerator and denominator. So I times x here and times x there. So they're still equal, right? Now, then I can do something here, which is x squared is 1 plus x squared minus 1. That is still x squared, right? Times sine ax dx over x 1 plus x squared. The reason of doing this way, I can split this integral into two. So this and that. So the first one, after cancel this one, becomes negative. This is cancel out. This is equal to sine ax and dx over x. Right? Now the second one will be plus this is sine ax dx over x 1 plus x squared. Yeah. For this one, sine ax over x dx, right? I can multiply by a times a both numerator and denominator. And this one is dAx. So the integral becomes actually becomes a sine ax dAx over ax. So that one is equal to pi, right? We know that the Dirichlet integral is that's a famous integral, right? Sine something over something d something from this one to this one, right? It's equal to pi. So So this one is equal to negative pi. Yeah. And plus integral uh, sine ax dx x1 plus x squared. Yeah, that's good. Then we take the second derivative of a with respect to a. So that will be 0, right? This is 0. Now this we take the second derivative. The derivative of this one with respect to a will be cosine ax times x, right? Because x is constant over x1 plus x squared dx. After cancellation of x, that's exactly my I, Oh, that's equal to I. Okay. Not my I. Sorry. It's not equal to f of a, all right? Not this one. This one. Cosine ax. Cosine ax. After cancel this one. So this was f of a. Yeah. So we have a differential equation. So f double prime of a is equal to f of a. That is a simple differential equation second order, right? So this means f of a equal to c1 e to a plus c2 e to the negative a. That is second degree differential equation. So that's easiest to get this one. Then, then I have a initial condition. Well, f of 0 is pi, right? So f of 0 is equal to pi. Now I'm using this condition. So which means pi is equal to c1 plus c2. Yeah. That is my equation 1. Yeah. Now my other condition, f prime of a, is this. So my first derivative at a 0 will be negative pi because this is 0. Huh? So this is my another initial condition, which means f prime of a 0 is equal to negative pi. When a equal to 0, f prime of a 0 is negative pi. So that one shows that negative pi is equal to this derivative with respect to a. That's a c1, right? This is negative c2. Yeah, that is when a equal to 0, right? After derivative. So this is another condition. So from these two, from this one, these two, I get a c1 is 0 and c2 is pi. Yeah, good. So my f of a is equal to pi e to the negative a. Yeah. Okay. So my I is equal to what? My I is f of a 1. F of a 1. This is pi e to the negative 1, which is equal to pi over e. Yeah, that is my very answer to this integral. It's a great, gorgeous. Thank you.